The rate equation for the reaction between compounds A and B is shown. Rate equals K, A, concentration of A squared, concentration of B. Figure 2 shows how the concentration of A changes with time in this reaction, and we're being asked to draw a tangent to the curve at time equals 0. So we're going to need to get a ruler, and we're going to take that ruler and we're going to line it up to the curve at time equals 0. Okay, so if you have a look, you want to be matching to the shape of the curve right at the start. So you want your ruler to be touching the line right at the start. There we go. And matching the curve right at the start. And then you want to be drawing a line down your ruler. Okay, a little bit tricky on an electronic device. Just move that slightly. Do that again. The ruler just needs to, because of the thickness of the pen, the ruler just needs to sit a little bit away from it. There we go, that's better. Okay, so we can see that I've drawn my tangent. Now, they're quite lenient on this particular tangent in the exam, as long as it was crossing through the on that y-axis at 0.5, and then it cuts the time axis anywhere between 5 and, so that's here, so they were allowing quite a lot of leeway, and 12.5 here, then they were giving you their marks. Okay, so I am then going to calculate, using that tangent, the initial rate. So initial rate is the gradient at time equals 0. So for mine, we're going to do the dy by the dx. And for my line, and obviously your line may be slightly different, remembering it can be within those parameters that we just discussed. My y, it goes from 0.5 to 0. I'm going to use the whole of the axes. My triangle encapsulates the axes. And then on the bottom, it goes from 0 when it was 0.5 to 10.5. Just the first square after the 10, they're going up in 0.5s. So I'm going to do 0.5 divided by minus 10.5. So I'm getting a negative rate, and you don't have to have the negative sign on rate tangents because it was a rate of loss, but mine's a negative gradient of 0.0476. Okay. So your tangent has to align with the line that you drew. The second part says the experiment was repeated at the same temperature with the same concentration of B but a different amount of A, and the new initial rate was 1.7 times greater than that of the original experiment. So we had before our concentration, in fact we can just use the abbreviation, can't we? We had our concentration of A and we had a rate. So our initial concentration of A was, just go back and check, 0.5. And it doesn't really matter what we calculated our rate as, but just because we did it, I'm going to put in the value, 0.0476. Now it says that the initial rate was 1.7 times greater. Okay, and it asks us what was the new initial concentration of A. Now what we have to remember is if we had all the data in this table, how would we have worked out the order with respect to A, which in the question is second order. Okay, so whatever we'd done here, whatever change had happened here, we'd have to square it to equal 1.7. So x squared equals 1.7, which means x equals root 1.7. Okay, so we want times 0.5 by the root of 1.7. And if we type that on our calculator, we get 0.65. So what we're saying is, if we think of it backwards, if the rate had gone from 0.5 to 0.65, we'd have done that on our calculator, that change. And we'd have said, oh, it changed by 1.3 times. Then we'd have said that whatever happened to rate would have had to change by 1.3 squared times because it was second order. And so if we look what 1.3 squared is, that's where we get the 1.7. So the rate going up by 1.7 meant that A had to go up by 1.7 square rooted, and then we just apply that to 0.5.